Sir.
So basically, the question is find the complementary function of t square plus 4 of y equals to 1. So this is actually, if you see this d, right, it is nothing but a differential equation. So it's nothing but d square y by dx square plus 4y equals to 1. That is the form of this equation. Okay.
Yes, sir.
So, whenever they ask you to find the complementary equations, right, complementary functions, so there are some steps. Basically, this particular problem, right, it is in the form something like y of x equals to e power rx. So we have to bring it to this form actually. Usually, whenever they ask you for finding the complementary equations, right? So
Yes, sir.
and right hand side you have to equate with 0. So this one will become d square plus 4 y equals to 0. This is nothing but d square into e power rx plus 4 rx 4 e power rx equals to 0, right? This is the form.
Yes, sir.
So if you see, like, since we are double differentiating, this will become r square into e power rx plus e power rx into 4 equals to 0. If you simplify this, it is nothing but e power rx into r square plus 4 equals to 0.
Yes, sir.
And if we simplify this particular equation, then we will get r equals to plus or minus 2i, right? The solution of this particular r square plus 4.
Yes, sir.
Because r square will become minus 4. The solution of this is plus or minus 2y, right?
Yes, sir.
Yeah. So usually whenever we have e power rx format, right? So then the complementary solution y of x, usually it will be uh, e power ax into cos bx plus e power minus ax into sine b1 and b2. Okay, b2 times. So here a is basically real part, b is the imaginary part. So this will become, so real part is 0 for both, right? So this is 1. But imaginary part cos of 2x, right? Cos of 2x
Yes, sir.
plus sine 2x, because this is also, all right, y of x. And we also will have the constant a and b, the integral constants. Okay. So from the solution, if you
Yes,
see,
sir.
they had given, like, instead of a and b, they have given c1 and c2, the option 3, c1 and c2.
Yes, sir.
So the solution is c1 cos 2x plus c2 sin 2x. Clear, right?
Yes, sir.
So next question, this is the first question. Next question, you need to find whether these two signals are orthogonal or not. I have
Yes, sir.
from 0, the amplitude is 1 up to 1, and then up to 3 it is -1. From 3 to 4 again 1. And I have this is x of t. I have another signal from 2 to 4. This is h of t. This is also 1 and -1. So we need to find whether these two signals are orthogonal. So we need, in order to find any signal, if they give you any signal x of t and y of t,
Yes, sir.
if you want to find the orthogonality, what you have to do is just you need to integrate from 0 to the maximum available value, or 0 to infinity, x of t, y of t. So when you integrate, if this result is 0, then the signals are orthogonal. So here, if I multiply x of t into, first just let's multiply x of t into h of t. So
Yes,
from
sir.
1, 0 to 1, both are high, so it will be 1. And from 1 to 2 it is -1 here also, but 1 to 2 it is 1, here it is -1. So from 1 to 2 it will become -1. This is
Yes,
1,
sir.
1 to 2 -1. From 2 to 4, this is actually 2 to 3, let's consider. This is -1, this is also -1. So 2 to 3 it will become this.
Yes, sir.
And from 3 to 4, this is -1, this is +1. So 3 to 4, it is -1. So what is the, if I integrate, so this is actually h of t into x of t. What is the result if I integrate?
So is it 0?
Correct. Yes. Can you tell me the reason why it is 0? So see, it's sum of all areas, right? So here it is positive area. So same area
Yes,
is
sir.
subtracted here. It will become, this get cancelled. So here it is positive and here it is negative. This area also get cancelled. So when you add it all the areas, it will become 0, right?
Yes, sir.
This is negative area, this is positive area. So that's why whether it's orthogonal or not, it's orthogonal signal.
Yes, sir.
So next, third question. X of t equals to e power minus at into q of t. So the question is whether for this equation the Fourier transform exists. Okay, Fourier transform exists if on what condition actually, based on what condition it exists, and if where it doesn't exist. So for example, for what value of a, so for example, if I consider a less
Yes,
than
sir.
0, for example, a less than 0 is like a minus 5, so x of t will become e power minus of minus, it will become 5t, right? E power 5t u of t. So if I plot this, it starts from 0 and then it keeps increasing, right? It keeps increasing. This is the
Yes, sir.
curve,
Yes, sir.
right?
Correct.
So this is like, this is the curve x of t. So
Yes,
Fourier,
sir.
as per Dirichlet condition, in order to the Fourier transform to exist, what is the first condition? Our Fourier, the x of t should be finite, right? If I
Yes, sir.
integrate, that is stable. If x of t is stable, x of t is stable means when I integrate that, I should get a finite value. So this is keep on increasing. If I integrate, will I get stable value or like constant value?
Yes, sir.
No. Here, if I integrate, keep on increasing, right? I will get actually infinity if I integrate.
Oh, yeah.
It's not a finite. So actually, see, if I say, if you have some curve like this, so area under this curve can be identified, but e power minus 5t, it keeps increasing. So it is unidentified, like keep increasing, so infinite. So if a is less than 0, that doesn't exist. Fourier transform doesn't exist. So if a equals to 0, whether it exists, it is e power 0 into u of t. This also doesn't exist actually, because 1 into u of t. If I integrate u of t, it is actually infinite. But actually, still the Fourier transform we can find for this using Fermi-Dirac, and like some methods are there actually. So some quasi base, like you can make it stable and we can use for this. So for this we can make it exist. And if a greater than 0, then your curve will become like this, right? Like decreasing, right? So if a greater than 0, like if I consider same condition, a greater than 0, 5, it will become e power minus 5t. That is negative exponent. So if I take the area of this exists, right? So the Fourier transform doesn't exist if a less than 0, because it goes to infinity, right?
Yes, sir.
Hope you got the idea.
Yes, sir.
So next question.
Yes, sir. I guess after that question, there is no Fourier transform questions. I guess we have to go back to the questions before 83. There are many questions.
Okay.
So check out the other PDF wherein the question starts from number 1. So I'll only tell which are the questions from Fourier transform there. So we can have it. So 54th question is a Fourier transform question. From 54, I found out 1, 2, 3, 3 questions till 56, and 59 is also a Fourier transform question. 53, 54, 55, 56 and 54, 55, 56 and 59th question. And yeah.
Yeah, which are the one? 54.
And 54, 55, 56 and 59, 60 and uh, yeah, and this one, which one? Huh. And 81th question I found out. If you find any others also, we can do it.
Yeah. 81, na?
Yeah,
Okay.
81. Okay.
Okay. One second.
Yes, sir. Please to check it and yeah.
Yeah. Yeah. 54th question is basically find the
Fourier transform of U of t
yes.
question. Yeah.
So if you see u of t, again, like it comes to the same point where it is not absolutely integrable. So if I take u of t, it's like u of t and
Yes, sir.
t, it is 1. So if I integrate from 0 to infinity, right? So 1 dt. So this will become infinite, right? Because like it keep adding. So it is like till infinite it is defined. So as per general Fourier transform rule, this is not absolutely integrable, right? We cannot directly find the Fourier transform. So what we have to do, it's like a little, usually for finding the Fourier transform of Q of t, we will use a trick. So if you remember, like in first or second class, I had discussed like if u of t can also discuss mentioned as 1 by 2 plus 1 by 2 of signum of t. So signum
Yes,
of
sir.
t is this, right? Plus 1 minus 1, both the side. And here actually, if I multiply 1 by 2 to this, so this will become 1 by 2, negative also 1 by 2. Now if I add 1 by 2, these portions will get cancelled. Only this portion will remain. It will add 1 by 2 again and it will become u of t. Right? So this is the standard formula. So from
Yes,
this,
sir.
actually we have to use this formula and we need to find the u of t. So now I can also represent this u of t as 1 by 2 into 1 plus signum of t. Right? So we know the Fourier
Yes, sir.
transform formula x of f is minus infinity to plus infinity x of t into e power minus j omega t dt, right? So here, as per the signum of t, it will become minus infinity to plus infinity. Half is there outside. E power minus j omega t, 1 into e power minus j omega t, plus integration from minus infinity to plus infinity signum of t into e power minus j omega t dt.
Yes, sir.
Right? So we know that actually the Fourier transform of 1, so I mean here 1, Fourier transform of 1, it's a standard formula. It is actually 2 pi into delta of omega.
Yes, sir.
Same way, the signum of t is 2 by j omega. This is a standard formula. These two are standard formula. So if I take the
Yes,
Fourier
sir.
transform of this, it will become 2 pi times delta of omega plus 2 by j omega. This is the Fourier transform of u. And half is there, right? Outside one half is there. If you
Yes, sir.
multiply, it will become pi delta of omega plus 1 by j omega. Right?
Yes, sir.
So that is nothing but option B, right?
Yes, sir.
Okay.
Hmm.
Next question is 55, right?
Yes, sir. Yeah.
Yeah. So next function is find the Fourier transform of e power 2t into u of t. So actual formula is integration from minus infinity to plus infinity. But since this u of t is 0 to infinity, right? E power 2t into e power minus j omega t dt. So this is a simple one. So it will become 0 to infinity e power 2 minus j omega t dt. So what is the formula? It is actually e power 2 minus j omega t divided by how much? 2 minus j omega from 0 to infinity, right? So yeah, how to simplify this?
UV rule.
No, it's a straightforward. I mean, we got this, but like now we have to substitute, right?
Straightforward. Okay. So I got confused with both. Okay, straightforward. Yeah. We are going to substitute 0 and infinity. One time 0, we are going to substitute for the whole, and minus second time, we are going to substitute infinity for the whole. Yeah.
Yeah. I mean, basically, if you see, this
Huh.
is going to be result in infinity. I mean, basically, if you substitute this e power infinity, it will become infinity minus
Yes, sir.
0. The resultant is infinity. But
Yes,
actually,
sir. Yes, sir.
as per the question 55, the answer is the Fourier transform doesn't exist. That is
Yes, sir.
infinity. So initially itself you could have identified, because when I say e power 2t, what is the curve?
Okay.
It is like this, right?
Yes,
So
sir.
if you integrate this, this is infinite. So for this, whenever it is a non-stable system or unstable system, then the Fourier
Yes,
transform
sir.
doesn't exist.
Okay. The logic. Okay.
So straightforward, as soon as you see that thing, right? So you can actually uh, say whether it is a Fourier transform exists or not. Okay, so that is a shortcut.
Yes, sir.
It's 80, right? Next question, 56.
So 56 and this one, sir, it is 56, 59, and 60. And 81 is the last question.
Yes. X of t is e power minus at square, right?
Yes, sir.
So x of f or x of omega, x of f, the Fourier transform is integration from minus infinity to plus infinity x of t, then e power minus j omega t dt, right? So
Yes, sir.
is it 80 square? Just a second. Yeah, correct. 80 square.
Yes, sir.
Okay, so this t square I have to just check how to resolve. So this maybe like we'll take later in the next class, this part. I will just check.
Yes, sir.
This t square part, I need to check how to resolve that. So, I mean,
So
some
just
rules we
a
have
minute.
to, pardon?
So just a minute. I'm sorry. 56, right?
Mhm.
56. Okay. Yeah.
I will just check and come back
So
to you. Okay. So
no, no,
that
no,
is
no. I
like,
just have the solution here. That is fine. I just have the solution here. So if we can check with that solution.
yeah, you can just
Uh,
share me like in the next class. I will
yeah.
just see that and
So
guide you.
yeah, sir, if you're on laptop, so you can just check check through your phone, sir. I'm gonna share it through WhatsApp now. So if
Sure,
you can just check it.
sure.
That is why I just
And 59 and 60, right? 59 and 60, that can be clubbed together. So 60. Actually, if you see in the Fourier transform of u of t, when we found
Yes, sir.
what two formula, right? So actually 1 plus signum of t, correct? 1 plus signum of
Yes,
t
sir.
of
Yes, sir.
half the time 1 plus signum of t. Then we found that two things actually, right? So one is
Yes, sir.
actually, if you see here, it is 2 pi times delta of omega and 2 by j omega. So this was actually the Fourier transform of signum of t, right? That is the answer for 59th.
Yes, sir.
What is the Fourier transform of signum of t? So what is this actually? This is a Fourier transform of 1, correct?
Yes, sir.
So 2 pi delta of omega. So this is actually, see, half the time
Yes, sir.
signum of t plus 1. So the Fourier transform of this will give you u of t, right?
Yes, sir.
So if you remember these three relations, so for all the three question you will get answer,
Yes, sir.
right?
Yes, sir.
Which is the other one you said? Which other?
So it is nothing but 81st question.
So actually, they have asked what is the Fourier transform of Dirac-Ohm. So Dirac-Ohm, do you know what do you mean by Dirac-Ohm?
I don't have that much idea, sir.
So Dirac-Ohm is nothing but it's a series of delta pulses. Okay, so it will be
Yes, sir.
like at t, 2t, 3t, so on. So you will be having the impulse pulses. So this is
Yes,
called
sir.
Dirac-Ohm. So the expression for Dirac-Ohm, right, is given by n equals to minus infinity to plus infinity delta of t minus nt. So this is the expression what we
Yes, sir.
usually get. So if we, as we know, if you want to find the Fourier transform f of omega, I have to integrate from minus infinity to plus infinity
Yes, sir.
n equals to minus infinity to plus infinity delta of t minus nt e power minus j omega t dt, right? So this is the formula. So if I
Yes,
simplify
sir.
this, right, so actually again, I mean, you can just like simplify this. So if you simplify this, you are going to get f of omega as 1 by t n equals to minus infinity to plus infinity 2 pi delta of omega minus n omega s. Okay,
Yes, sir.
so this, so what is this? Again, it is a Dirac-Ohm, right? Dirac-Ohm. I mean, if you see here, it is a scaled version 2 pi by t, scaled version of again one more Dirac-Ohm, right? N equals to minus infinity to plus infinity delta of omega minus n omega s, right? This is the scaled version of same thing. So that's where
Yes, sir.
the Fourier transform of Dirac-Ohm is again a Dirac-Ohm.
Yes, sir.
Okay, so that is the answer. You can see
Yes, sir.
answer number B, right?
Yes, sir.
Okay. Okay, so that one question maybe like give me some time. I have to go through that. But apart from that, you want me to solve any other problem?
Sorry, any other problem in the sense? Just a minute, sir. I also need just 2 to 3 minutes to check it once.
Okay.
Mm, actually, I need on convolution and correlation. I'll just check whether any question is there on that actually.
There are actually some questions in the part B of the PDF what you have shared. So in the next class, I'll gather those questions, discuss on that convolution, correlation, and some. If time is there, then maybe like we can discuss on some of the problems on transforms, set transform.
So, but Z transform is okay, sir. I can manage because I have some idea on Z transform and model number one. That is the basic on signals. So, but I don't have any idea on say this one. That is convolution. I have a bit confusion. And in the first PDF also there are many things. So that is 35th question is there. That is y of n is equal to x of n convolution of h of n. That thing is there. And there are many questions on correlation also. So I want only that much, sir, from signals.
Okay, okay, sure, sure. Then maybe like in next class we will cover that. Okay.
Okay, sir. So because Z transform is nothing but we have a table now. So if you just
Yes.
learn the table, say you can just try to tick mark the options, sir. Because the transform of that particular he'll have. So if we can correlate with the table, so we can just identify how does that work. So
Correct.
and there are many questions on Z transforms. No, in the textbook I have still. So there are many questions on Z transform. So we can just make a list of what are the answers of that question. So that that kind of questions nearby will come, so we can just take market. But these I wanted, so that's all.
Sure, 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 sure.
Sir, and did sir discuss about networks? Sir, I also wanted that. So did he tell
Network, I'm
anything?
not sure. Maybe somebody else
Huh.
can discuss on that. Networks, some other faculty will.
Okay, sir.
Okay.
Okay, okay. So networks in the sense I had a few doubts with respect to that also. So that is why. Sir, actually, what's the problem is it's a lengthier process, you know, how network analysis goes on. And
Yes,
that
yes.
one we can't put it in exam. So that is what is the major problem that I have now.
Okay.
Because those bigger things can't be done. And I guess networks have some good weightage in part one.
Yes, yes, yes.
Yes, sir.
Sure,
Okay, then, yeah.
sure. Okay. Thanks. Bye.
Yes, sir. Okay, then shall we'll continue tomorrow with that
Sure,
convolution and correlation, and
sure,
then we'll wind up the signal, sir. Only that much doubt I had. Okay.
sure, sure, sure,
Sure, sir.
sure. Thanks.
Okay, sir. Thank you, sir.